All right, this is a video about molarity. Okay, now molarity is a unit of concentration. Now, what I mean by that is we have in the past talked about, the percentage of like a solute per solution, right? Where we have, say, if I had 5 grams of sodium chloride, okay, and then I dissolved it in, say, 15 grams of water, right? That would be 20 total grams of solution, right? And I do the division and I end up with a 25, right? By do the division, multiply by 100, right? I end up with 25% sodium chloride. That's a 25% sodium chloride solution, okay? So that's just an example of a concentration. Okay, there's other units of concentration. There's parts per million and parts per hundred, or this is what parts per hundred is. But parts per billion, you hear different concentrations. Well, molarity is yet another concentration, and the formula for molarity is the moles. Right now that we know what moles are, the moles of a solute divided by the liters of solution. Okay, liters of solution times 100 equals molarity. Okay. Now, this is important because molarity, which is capital M, it is the principal unit of concentration when we do chemistry in a laboratory. So you may have heard me refer to things as something something molar, like 3 molar or 0.1 molar, right? Molar is referring to the molarity or the concentration of that solution in molarity. Okay, so if I was to look at, say, I don't know, let's go with that 5 grams of sodium chloride, right? And it's dissolved in, say, 1 liter of solution, meaning within this 1 liter of solution, there is 5 grams of sodium chloride. What's the molarity of that solution? So hopefully it's, just like many of the other problems that we have, we can always go back to this guy right here, right? And we can go, the molarity is going to be moles over liters, right? And that equals molarity. So if any time you're given 2 of these 3 variables, you should be able to cover one of them up and then solve for the last variable. In this case, I'm trying to solve for molarity, so I'm going to cover up molarity, and I have moles over liters. Well, looking here, I have grams, which obviously is not moles, but I should be able to use the molar mass, right? If I use the molar mass of sodium chloride, which would be 22.99 grams per mole plus 35.45 grams per mole, I end up with 58.44, about right, grams per mole. All right, sorry, I wanted to check that because it's a long day. So anyways, so my molar mass for sodium chloride is 58.44 grams per mole. So from that, right, if I start with 5, let's go ahead and say it's 5.00 just to make the sig figs happier, right? 5 grams of sodium chloride over 1, and then I know that there is 58.44 grams of sodium chloride for every 1 mole of sodium chloride, right? I'm going to go 5 divided by 5 divided by 58.44, and that equals, with 3 sig figs, 0.0856, right? But I'm going to multiply that by 100, right? Well, where'd that come from? So anyway, not multiplying by 100, you're just going to do the division, and this ends up being the number of moles of solution, okay, or the number of moles in the solution. So if I have the number of moles now, I can really apply this guy right here, which would be no longer, right? Now it's 0.0856 moles of sodium chloride per every 1 liter of solution. So in that case, my molarity is going to be 0.0856 molar. Okay, so that's how I calculate molarity. I'll give you another example. So if I had, let's say, 25.6 milliliters, keep milliliters, it's important, right? Because we'll get back to the equation, but it's not liters. We got to make sure we do some conversions here. So 25.6 milliliters of solution contains 36.4 grams of, cut that down to just 6.4 grams of sodium chloride. We'll go ahead and stick with sodium chloride since we already have the molar mass for that. Okay? What's my molarity? Right? So I know that molarity is equal to moles over liters, right? Well, the moles, I have to use the molar mass of sodium chloride, so 6.4 grams of sodium chloride over 1, 58.44 grams of sodium chloride over 1 mole of sodium chloride. And then, well, that's the end of the road because I have my moles of sodium chloride. So I'm going to go 6.4 divided by 58.44. That equals, with 2 sig figs, 0.11 moles. Okay, so my moles is 0.11 moles, right? And then my liters, well, I don't have liters, I actually have milliliters. Now we need to convert that into liters because that's the formula for molarity. So I'm going to go 25.6, right, from right here, 25.6 milliliters over 1. And then I know that there's 1,000 milliliters for every 1 liter, right? So my milliliters cancel out and left liters. So I'm going to go 52.6 divided by 1,000 equals 0.0 with 3 sig figs, 256. Okay? So now this is my volume in liters. So 0.0256 liters, 0.11 divided by 0.0256 equals 4 with, in this case, 2 sig figs, 4.3 molar. That's the concentration of that solution in molarity, right? So if I have 6.4 grams of sodium chloride in 25.6 milliliters of the solution, I have a molarity of 4.3. Okay? So obviously you could rearrange this as long as you have the proper units, right? It needs to be in liters, and this needs to be in moles, right? But you can calculate molarity, moles, liters, as long as you have 2 of the 3 variables. Okay? So if you guys have any questions, by all means, send an email or ask.